Hi and welcome to the 3D printing bunker with the Bidder Thinker. Today we are going to disassemble Ender 3 once again. Hopefully in this time we can assemble it and make it work as it should. See you in 10 seconds. Okay, let's start disassembling everything. First of all, we will disconnect the USB cables. Then we will pull out covers. And last thing we are going to do is pull out the housing for the everything, really. Okay. Let's disassemble the LCD screen. So disconnected, and let's pull everything out. Okay, let's see what we have to do. We have to get everything from here out. And of course, my memory was full on camera. Okay, so we already got now this part. Okay, so this is the new case for the electronics. Let me screw this screw in and I will be right back. And the case is now fixed. Okay, let's remove this board first. Let's check the screws I have here. So this time I have short screws. And let's use those short screws to screw in the SKR 1.3. It's good that the board isn't powered, because probably I would blow every fuse or electronic component there is. And SKR board is finally fixed. When I said fixed, I mean firmly screwed in. Let's get those cables out. Let me fix this. Okay, let's insert the Raspberry Pi, and the Raspberry Pi should go like this. This is really a tight fit, but this will not go anywhere. Okay, let me get the fan. I've got a bit larger fan. Let me check screws I have here. this should be it. Let's power it. I'll not really power it, but connect it. Okay, this is connected. Now what we'll do, I've got a new relay here, normally open, normally closed and common, with high and low, and this one I hope will be able to control the let me see how I put it. This one will probably be able to finally control the power of the Ender 3 printer. And we will put it in normally open. Why? Because if we lose power or anything, we want it to be disconnected. What else? Those, yeah. I need connectors that are male, female. Well, nope. I will remove the connectors on one side and then, yeah. Okay. Okay, the wires are cut. What we have to do next is connect them here. So plus, minus, and okay. Plus will be yellow, orange will be minus, and red is data. Okay, the wires are now in. So we have here enough slack. We can even put it like this. Yeah, that should be, no, it's better like this because let me first install buck converter and I will see where it will fit better. If you are looking at this and experiencing some kind of rage attack on how I'm doing this, please leave me a comment down below. It's always nice when you can get emotions out of somebody. So, okay, this part is done. Buck converter is in. Now let's put the relay in. Let's see where it fits better. This is it. We don't need this anymore. This is extra. We don't need this anymore. What's left to do? Okay, later on I have to connect those wires to the Raspberry Pi, plus, minus, and I have to choose what will I be using, high or low. I think I will be going with low and then pull up the 3.3 volts out of the GPIO. But now, let's pull this out. And we will be replacing them with brand new TMC 2209. But before we can do that, we have to remove all the pins. I hate those jumpers. I'll be right back when I finish it. Several hours later, finally all the jumpers are out. Okay. Yeah, I do have to pull those pins out too. Finally, okay. Let them. Okay, so now since we have removed our jumpers, let's put them back in. What's left to do? This is the first. Okay, so let's see. I think I got most of the things covered. Next, we have to connect relay to the Raspberry Pi. Okay, let's connect. So we'll be using 3 volts. So 3 volts is this one. Next, we need ground. This is first, second, third. We'll be using 1, 2, 3, 4 this pin for signal. That's GPIO 4. Okay, I think more or less everything is connected. I have to reassemble it. I have to connect the stop again to the board, and I have to reconnect this stepper driver and the Y stepper driver and the end stop. Okay, let me try and insert the housing here. It should go here. Everything looks connected. Okay, let me clean this up a bit and I will be right back. Okay, this is it. Everything is connected there. Wires are back inside. And let's see if we can now close this somehow. And everything is secured, fixed, cables tied. Let's gently move heat bed or bed. Everything is okay. Okay, so this part of the upgrade is finished for the second time. Next, what we have to do is we have to go to the Merlin or to the Atom and compile the newer version of the Merlin for the TMC 2209. Oh yeah, and fix also in Octoprint relay part to... Maybe this wasn't such a good idea to do it. Okay, no problem, but first I have to set up the Octoprint to have printer running when I want to, or to switch it on and off. Unfortunately, if I don't fix it now in the Raspberry Pi, I will not be able to boot it and put new TMC 2209 drivers. As this video is getting longer, I will wrap up today with the first prints or test prints or calibration prints. Next time I will go through firmware upgrade or installing newer version of the firmware that has been configured for the TMC2209. But let's first look at what I did after I assembled the printer and after I flashed the new firmware on the board. So first thing I did is, of course, I did extrusion test, or to check extrusion of the TMC2208 in comparison to my old extrusion. So this is the original length. It was, you will see it picture here, it was 96, I believe, millimeters long out of 100 that was needed. And this one is after I changed my E-steps 100. This is 100 and 100.1 or 100.12 probably, but more or less it's for now okay. What I didn't do is I didn't test flow rate. I have still to test that. After that I did retraction speed test. So this is the standard test for the retraction. As you can see, anything above 4.4 millimeters, 4 millimeters, yeah, 4 millimeters is okay. So I will be keeping my 4 as previously. No stringing, no ghosting, no artifacts on the side and front. So more or less this is really nice print for the retraction test. After that, problem started, so I tried printing the speed test, and this is the result. So this should be like this. It just stopped extruding at one point. I didn't know what happened, so I canceled the print. Then I printed this one and it was successful. As you can see, this is the DevilDesign PLA Polish manufacturer. More or less anything higher than 200 degrees is okay. 195 and 190 are not so good. These detached after I took the print of the bed, but still you can see that the filament just didn't bond. So yeah, I will probably print between 220 and 225. There is a reason why I go so high with this filament. I had some problems after my first upgrade attempt. I installed A4988 stepper drivers and I had problems for 2 weeks with the printing. So then I increased temperature to 230 and everything printed well. But I will now lower it and probably print other prints between 220 and 225 degrees with this filament. But as you can see, this one printed okay, so this is successful, this was successful. And after that I started to print again the speed test, and once again you see this failed print. But what's fascinating about those prints is, as you can see, it starts under extruding at one point, then it completely stops extruding or something like that, then it restarts extruding and it finishes nicely. It doesn't detach, it even corrects itself with these overhangs here and starts printing nice form as it should be. So this is very nice to see, but this is failed print once again. And I discovered what was the problem, and that's really strange one. I had it previously, and while I was eliminating possible factors, I eliminated among things that too, and I forgot to eliminate it this time. The issue is my filament runout detector. So whatever way I put it, it just gives too much grip on the filament. and as filament is going from the upper part of the so filament is on top of Ender 3, there is an arm that's pointing the filament away from the printer, so you get nicer curve. But even if I put the filament detector here, or if I put it right on top, it just, with this loop, it just blocks the filament, and the extruder unfortunately doesn't have a good grip on it, and it stops extruding up to the point where you really do not have any filament left in the nozzle. So this was the second failed attempt. After that, I removed filament runout detector, and I printed this one. So this one is really from the 50 millimeters up to 100 millimeters speed, every 5 millimeters in height. So as you can see, it prints great all the way up to 100 millimeters. I will probably not be pushing it that far. I will probably go between 70 and 80, probably 75. I don't know why I choose that number, but I already did a couple of prints with it and it's okay. So the test for the speed went okay, and then I went with the all-in-one mini test. And while we do not have that much bridging issues, bridges are okay. We do have a bit of stringing here. You see some artifacts here on the side that I just don't like. Yeah, the printer still isn't completely calibrated, and I will definitely have to play a bit more with the temperature, with the retraction speed and things like that. There are some strings here, as you can see, and here too. So yeah, if you look at generally, if you look at it as a big picture, more or less all the tests did complete nicely, but you still see some kind of artifacts here and there. And the overhangs printed very nicely, as you can see, up to 70%. So yeah, that's okay. This is with the stock part cooling fan. So yeah, on the one side I'm happy, but on the other side there are still a lot of things to work on. I will still have a lot of things to do with my Ender 3 printer to get it up to the quality I want. Okay, and there will be part 3 of the series. Why? Unfortunately, this episode also was too long, so I didn't want to make a marathon of 3.5 hours of everything. In the next episode, I will go to the firmware changes I did. I will also, in the next episode, include 2 versions of my firmware that I downloaded. Bear in mind that both of those versions will be without ABL, but with the filament runout sensor. And one will be for the A4988 stepper drivers, and the other one will be for my brand new TMC 2209 stepper drivers. I also had 2 firmwares, I also did 2 firmware upgrades for TMC 2209. I did test, I did print something with my first version of TMC 2209 firmware for the SKR 1.3, of course Merlin 2.0 or Bugfix 2.0 version. But I also worked on some other stuff that I found on the internet. So yeah, so if you want to see from grounds up how you install and get everything ready for TMC 2209 with the SKR 1.3 board, check out my next episode, and I hope that by that time my original BL Touch will arrive, since I did test the original BL Touch I received and it works great. I just don't want to mess up my heat bed with it, so I'm waiting for the original BL Touch to arrive. So I hope to have in the next episode also BL Touch installed, and then I will compile a couple of versions of Merlin and I will also post them so you can download with all the settings included. Thank you once again for watching 3D Printing Bunker video from Bearded Thinker. If you have any kind of a suggestion or a comment, please leave it down below in the description. If you still haven't subscribed, please subscribe and hit the bell button so you get notified. And I will be seeing you next time. Until then, bye bye and have fun.